Hi ho there, student arenos. Mr. Kaczynski here with you. We're going to do 4.6 practice your skills. And here we go. We're off. Got a lot of them to do, but they're pretty repetitive. In each pair of expressions equivalent? If they are not, change the second expression so that they are. It says check your work by comparing tables and values for the equivalent expressions on your calculator. Okay, so I think the idea is that we want to actually use the distributive property to simplify this expression. So I'm going to do negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. And then when I simplify that by combining like terms, 3 and negative 12 makes negative 9. I can see that they both have the minus 9, but this is a positive 3 compared to my negative 3. So if they're not, change the second expression. Okay, so I'm going to change the second expression to negative 3x minus 9. So not equivalent, and there's my second expression. All right, so this one, we'll distribute that 2. 2 times x is 2x. And then 2 times negative 2 is negative 4. And then combine like terms, 5 and negative 4, we end up with 2x plus 1. So these are equivalent. Let's just type that in. Maybe I should use the orange. There we go. So I think on this one, we probably want to take the second one and simplify it. So let's make it 2 plus 5x minus 5. That's what you get when you distribute here. And then combine like terms. 2 and negative 5 makes negative 3, and you still got the 5x. So those are equivalent, aren't they? And this is probably one of the easier ones. We don't have to do any combining like terms, but we do have to distribute a negative, and that might mess some people up. So negative 2x, which is negative 2 times x. And then I look at this as negative 2 times negative 4, which is positive 8. So these are not equivalent. So how would we fix it? I guess we would want to change the other one to, or the right side, to negative 2 times x plus 4. That's what we should change that to, and then they would be equivalent, because then you get negative 2x minus 8. Rewrite each equation in intercept form. Show your steps. Check your answer by using the calculator graph or table, which reminds me, I kind of skipped this idea of checking that both are equivalent. I think we'll just do that with this one. We'll call it good. Here we go. So we want to turn this into intercept form. So to do that, we're going to distribute 3x minus 15. And then we combine like terms. So 14 and negative 15 makes negative 1. So there's the answer. Let's check and see if that works. Y equals, we got our original 14 plus 3 times the difference of x and 5. And then we've got our intercept form, which is negative 1 plus 3x. And if we go second graph, we can see that their tables are the same. And if we actually do a graph, we can see that only one line shows up because they're the same line. All right, on this one we did to distribute the negative 2, so it would be negative 2x and then negative 10. Negative 2 times positive 5 is negative 10. Combine like terms, negative 5 and negative 10 makes negative 15. I'll check this one, but I'm not going to check them all just for time's sake. Guess we'll just have to trust me, right? So x plus 5 in these parentheses down here, negative 15 minus 2x. Hit second graph, and all we're looking for is those tables to be the same, which they are. Ooh, all right. Let's see, what do we do here? We are going to subtract 6x from both sides. So it would be 24 minus 6x on the right. and then we'll divide everything by 2, and that gives us 12 minus 3x. We can't really punch both of these into a graphing calculator because the graphing calculator requires that we have them both solve for y, but this is a place where Desmos.com might be an advantage to us. So let me bring that up here. So let's go to Desmos. Oops. Let's go to the graphing calculator. We'll type in our original 6x plus 2y equals 24. Oh, need an equal sign. There we go. And then we'll put in this other one, y equals 12 minus 3x. And you can see that line went right on top of the other one. So that means they are equivalent. I'm going to do that another time here. So first thing I got to do is subtract 3x from both sides. That gives me 12 minus 3x on the right, negative 3y on the left. Divide everything by negative 3. 12 divided by negative 3 is negative 4, and negative 3x divided by negative 3 is positive 1x, or just x. So that's the answer there. This one, I'm going to distribute that negative sign first, so negative x minus 2, and then I'll add 6 to both sides. So negative 2 plus 6 is 4, so 4 minus x. And on this one, we just have to distribute, so 7 times x, 7x, 7 times 3, 21, and then combine like terms, so 21 plus 4 is 25, plus the 7x. There we go. We put them all into intercept form. Moving on. Solve each equation by balancing. Tell which property you used for each step. So on this one, if I divide both sides by 3, I get x equals 4. So as far as this part, tell which property, I'm just going to say that out loud. The property I used is the division property of equality. The division property of equality. All right, let's do this. Negative x equals, let's see, 47 plus 45, I know is 92. And to do that step, I use the addition property of equality. The addition property of equality. And then I know the answer is negative 92 because if I divide both sides by negative 1 using the division property of equality, I get that answer. Or you could say the multiplication property of equality, because if you multiply both sides by negative 1, you get the same result. All right, let's subtract 15 from both sides. You get x equals negative 7. So to tell which property I use, that would be the subtraction property of equality. Subtraction property of equality. This one, multiply both sides by 4. 4 times 20 is 80. 4 times 8 is 32. So 112. And I use the multiplication property of equality. Multiplication property of equality. This one I'm going to show a little bit more work. I'm going to multiply both sides by 7. I'm allowed to do that because of the multiplication property of equality. The multiplication property of equality. And that'll give me x equals 21/4. That's what I would go with. 21/4. Started with fractions in the equation. We should probably finish with fractions for our answer. And on this one, let's just add 3 to both sides using the addition property of equality, and we get 10. The addition property of equality. Distributive property. Here we go. Let's rock these out. You know, we really did tougher problems than this already using the distributive property. This one's 3x minus 6, negative 4x plus 20, because negative 4 times negative 5 is 20, negative 2x minus 16. I look at negative 2 times positive 8 is negative 16. 5x minus 5, negative 3x minus 6, as in negative 3 times positive 2 is negative 6. And this one's got a couple steps, so start here by doing distributive property. Then we'll combine like terms. 30 minus 12 is 18. So 2x plus 18 is what we'll leave for our final answer. All right, now these we're going to actually work backwards to do a process called factoring. So the first thing we have to do is identify what's the greatest common factor of 3x and 12. I know that they are both divisible by 3. And then I ask myself, 3 times what is 3x? 3 times x is 3x. And 3 times what is negative 12? 3 times negative 4 is negative 12. So these are equivalent. It's like doing the distributive property backwards. All right. If the lead coefficient is negative, we should factor out that negative sign. So I'm going to call negative 5 their greatest common factor. They're both divisible by negative 5. Negative 5 times x is negative 5x. And negative 5 times negative 4 is positive 20. These are both divisible by 4. So I'll say 4 times 8 is 32. And 4 times x is 4x. So that's called a factored form. Take a negative 7 out of these. Negative 7 times x is negative 7x. Negative 7 times positive 4 is negative 28. Both of these are divisible by 9. It'd be nice if they gave us one. Oh, there it is, k. Yeah, we'll get to one that doesn't have the lead coefficient always be the greatest common factor. So 9 times x and 9 times negative 3. Take a negative 5 out. Negative 5 times x is negative 5x. Negative 5 times 5 is negative 25. These are both divisible by 12, so we'll go 12 times 4 and 12 times x. These are both divisible by 8. 8 times 1 is 8. 8 times negative x is negative 8x. These are both divisible by 4. 4 times x is 4x. 4 times negative 3 is negative 12. That one kind of feels like a up here, but we factored out a 4 instead of factoring out a 3. These are both divisible by negative 6. Negative 6 times x is negative 6x. Negative 6 times negative 1 is positive 6. And I like this one, okay. These are not both divisible by 10. They are both divisible by 5, though. 5 times 2x would give me 10x, and 5 times 3 would give me 15. All right, so that's called factoring. It's the opposite of distributing. And that's all I've got for you. Have a great